Welcome students to my YouTube channel, that is DD Civil Engineering. In today's lecture we are going to study unit number 5, that is axially loaded column, okay, of MOS subject from degree Civil Engineering. So this diagram is of column. As in our unit number 5 we are going to study the columns, axially loaded columns. Actually, as we all of you know that column is a compressive member. Suppose this one is the column, this one is the length of that column, one end is fixed, and over this P load, compressive load is acting. P is nothing but the compressive load and L is nothing but the length of the column. So column is nothing but the a member which carry only axial compressive load, and that member we can call column. It is a vertical member. Column is a vertical member which carry only axial compressive. Vertical member which carry only axial compressive load. Okay, why axial compressive? Axial compressive load means this is the axis of the column, and along which the axis from which centroid, this axis passes through the centroid of the column. So, and along this axis our compressive load is acting. So that's why this load we can call as axial compressive load. So here there are some terms given. We will study their definitions. Okay. First one is the strut. So strut is nothing but the inclined member which carry compressive load or subjected to axial load. Okay. So what is the difference between column and strut? Both are carrying the compressive load or axial load, but column is a vertical member, strut is an inclined member. So here diagram is given of the strut. This is supporting wall. One horizontal member is connected to the supporting wall, and another inclined member is supported to this horizontal member. So this member is known as inclined member, and this inclined member is nothing but the strut, because strut or inclined member carries the compressive load, okay, or axial load. So that's why this member we can call inclined member, and this member only fails due to crushing. So when strut fails, so we can analyze that strut is failed due to the crushing. Second, column. Already we have studied the definition of column. Column is nothing but the vertical member subjected to axial compressive load. Next term is what is by crushing load. Crushing load means the load at which member fails due to crushing only. Okay. Normally members fail due to crushing, buckling, okay, or crippling, like this. So the load due to which member fails crushing only, so that load we can call crushing load. What is in by crippling load? Also known as buckling load, also known as critical load. So load at which member is going to buckle, that means bend. So that type of load we can call crippling load, buckling load, or critical load. So, and this crippling of the member depends on the end conditions. Okay. So when column buckles, or how the column buckles, that depends on the end conditions of the column and eccentricity of the loading. Eccentricity of the loading means suppose this is the column. Okay, so this is the top surface of the column, and here axis of the column passes. So if load is acting on the axis, then eccentricity is 0, and eccentricity means the point of application, the distance between point of application of the load and axis of the column. So if our load is acting at this point, and this point is at a distance x from the line of axis of the column, then we can say this column has a or the load is this column is eccentrically loaded. Okay, so this distance we can call eccentricity. So this one is the eccentricity of this loading. Okay, so depending upon the eccentricity of the loading and also the end conditions, that means whether the both ends of the column are fixed or one end is free, another end is fixed, or both the hinged, depending upon that end conditions, crippling or buckling may happen. Okay. So next term is nothing but the radius of gyration, which is denoted by k. Okay, so what is meant by k? Is nothing but the radial distance of a point from the axis of rotation at which whole mass of the body is assumed to be concentrated, and that is nothing but the radius of gyration. That means if suppose this is the it is nothing but the radius distance. Suppose this is the point where all the siege of the mass is assumed to be concentrated, and this point is of axis of rotation. So distance between these two is nothing but the radius of gyration. Radial distance of a point from the axis of rotation at which whole mass of the body is assumed to be concentrated is, that is nothing but the radius of gyration k. So I, as I is moment of inertia, can be written as I is equals to a into k square. So k square will be equals to I upon a. If we take square root on both the sides, then our equation becomes k is equals to square root of I upon a. To find out the minimum radius of gyration, so k minimum will be equals to root of I minimum upon a, where k minimum is nothing but the minimum radius of gyration. When we will get k minimum? When I is minimum. And how we will get I minimum? Minimum value between Ixx and Iyy will be your I minimum, and from that, by putting I minimum into this equation, you will get k minimum. Okay, so I minimum will be equal to minimum moment of inertia between Ixx and Iyy. A is nothing but the cross sectional area of column section. So next term is effective length of column. So what is meant by effective length of column? Actually, suppose this is the there are two terms of regarding to the length. Okay, actual length and effective length. Actual length, the length which is measured from top to bottom of the column, that is the actual length. But while designing any column, okay, you have to take effective length, not you have to take actual length. Okay, so what is my effective length? Effective length is nothing but the distance between successive point of zero moment. Okay, so where the points at which zero moments are there, zero moments are acting, the distance between these 2 points is nothing but the effective length of column. So this effective length of column depends upon the end conditions of column. So we are going to study, there are 4 end conditions of the column. So first condition of the column is, if both ends of the column are hinged, then effective length will be equals to your actual length. ओके, जेवढी काही तुमची ॲक्च्युअल लेंथ असेल कॉलमची, ती तुम्ही काय करणार, कॉलमला डिझाईन करण्यासाठी किंवा ॲनालाइज करण्यासाठी ती लेंथ घेणार ॲज अ इफेक्टिव्ह लेंथ. ठीक आहे, दिस डायग्राम एक्सप्लेन्स both ends of the column are hinged. This line represents column. These 2 points, that means 2 ends of the column. Dot represents conditions, that is hinged conditions. So hinge condition represented symbolically by the dot. Okay, dot. And P, okay, P, these are the 2 P forces, that means compressive forces. You can see nature of these forces are compressive, because this acting upward direction, this acting downward direction, and both contributing towards compressive load, compressive forces. And if these compressive forces causes the column to bend or buckle like way, like in this nature. Okay, so if this is the condition, then your effective length of the column will be your actual length. Second condition is both ends are fixed. So this is the graphical symbol, okay, or diagrammatically symbol for fixed end, to show the fixed end. So vertical line, then inclined lines represents the fixed end, okay. And this pp acting compressive in nature, acting on this fixed column, okay, who has the both ends are fixed. So if this is the condition, then your column will be buckled at a distance from a support, okay, support. So from this length your column will be buckled or bend like this. So this will, if L is your actual length of the column, then your effective length will be equals to L by 2. That means half of the actual length you have to take as the effective length for the calculation or analysis purpose of the column, okay, or design of the column for that, or to calculate the critical load of the column. For that you have to take, or you have to calculate effective length. Next condition, if one end fixed and other end is hinged. So the AB, suppose this is AB column, okay, so A end is hinged because this is because dot is represented. So from dot we can recognize this support is hinged support, this support is fixed support. So one end is fixed, other end is hinged. So in this case again these forces are in compressive nature, okay. Then your column will be buckled like this from hinge, starting from here and then towards fixed at this distance and then like this. So your DL is total length, actual length of the column, then your effective length will be equals to L by root 2, okay. Then fourth condition is if your column is has one end fixed and other end is free. Suppose this is, okay, AB column, so one end is fixed B, this is the original position after applying the load, compressive load, okay, or load at the free end, it will move like this, and this is the extensive portion of the column, okay. So this one is your actual length and this one is your after buckling length, okay. This length you should add to calculate the effective length, and that's why your L effective will become 2 times of actual length, okay. In this case if one end is fixed and other end is free, you have to double the actual length and okay, you have to double the actual length to calculate the effective length, and from effective length you can calculate the critical load acting on this column, okay. So next term is slenderness ratio. What is meant by slenderness ratio? It is denoted by lambda symbol, okay. Pronunciation of this symbol is lambda. So it is the ratio of effective length of column to the minimum radius of gyration of that column section is called as slenderness ratio. So lambda will be equals to LE. LE is nothing but the effective length of the column divided by K is nothing but the radius of gyration. Minimum represents minimum radius of gyration, and this called as lambda, that means slenderness ratio. So next, classification of column. Depending upon the length, you can classify the column as a short column or long column, and also depending upon the failure condition you can describe what is by short column and what is by long column. So short column means when the column fail only because of crushing or direct compression, that column you can call short column, as a short column, okay. जो कॉलम हा फक्त क्रशिंग किंवा डायरेक्ट कॉम्प्रेशनमुळे फेल होतोय त्या कॉलमला तुम्ही काय डिफाइन करू शकता ॲज अ शॉर्ट कॉलम. अँड लॉंग कॉलम मीन्स द कॉलम विच इज फेल ड्यू टू द बकलिंग ओनली or bending, okay. So when the column is failed due to bending or buckling only, then that column you can describe as long column. So here two diagrams are given. A diagram represents the short column. So this one is the short column diagram. P is acting on the column. Okay, P is the compressive load acting on the column, and like this is the failure condition of the column, that this represent as crushing failure. Our column crushed due to the compressive load. And B is the diagram for long column. This one is the long column. Compressive load is acting on the column, and due to the slenderness ratio means, as long column means it has a length more than the short column. Okay, so due to this, when load is acting, it will tends to buckle like this, and due to the buckling it will fail, and this type of column you can call long column. Okay, so there is a theory. Next topic is, there is a theory which described to determine the critical load acting on the long column, and the scientist who have invented that theory, or who have described that theory, known as Euler's. Okay, so Euler's theory for long column we are going to study. This theory is used to determine the critical load acting on the column. Okay, so this theory is only used for long column and not applicable for short column, and this is the disadvantages of the Euler's theory, or limitations of the Euler's theory. Because what is the limitation of Euler's theory? This one is the one limitation, that Euler's theory we cannot use for the short column. This Euler's theory only applicable for the long column. So before studying the different formulas derived by Euler's, he assumed some assumptions first. Okay, so let's study what are those assumptions. Okay, before deriving the formulas for critical load, depending upon the different end conditions of the load column. Okay, सो कॉलमच्या ज्या वेगवेगळ्या कंडिशन्स आपण बघितल्या, एंड कंडिशन्स, 4 कंडिशन्स बघितल्या आपण. सगळ्यात पहिली कंडिशन्स बघितली आपण, बोथ एंड्स आर हिंज. कॉलमचे दोन्ही एंड हे जर हिंज असतील तर इफेक्टिव्ह लेंथ काय, एक एंड हिंज दुसरा फ्री, एक एंड हिंज दुसरा फिक्स्ड, नंतर दोन्ही एंड फिक्स्ड, नंतर एक फिक्स्ड आणि दुसरा फ्री. ह्या ज्या 4 एंड कंडिशन्स आहेत कॉलमच्या, त्याच्यानुसार आयलरने क्रिटिकल लोडचे फॉर्म्युले डिराईव्ह केलेले आहेत. मग ते डिराईव्ह करण्यापूर्वी त्यांनी काय केले, काही अझम्पशन्स अज्युम केलेत, मानले. तर ते अझम्पशन्स त्यांनी कोणते मानलेत ते आपण बघूया. आणि जे काही फॉर्म्युले आपण बघणार आहोत ते फॉर्म्युले कोणासाठी असतील, लॉंग कॉलमसाठी. कारण आयलर थिअरी फक्त कोणासाठी आहे, लॉंग कॉलमसाठी त्यांनी डिराईव्ह केली आहे. ठीक आहे, मांडली आहे. So first assumption is load on column is exactly axial. Okay, जो काही लोड असेल कॉलम वरती तो ॲक्शियलच असेल. नेक्स्ट, सेल्फ वेट ऑफ कॉलम इज निग्लेक्टेड. त्यांनी क्रिटिकल लोडसाठी वेगवेगळ्या एंड कंडिशनसाठी फॉर्म्युले डिराईव्ह करताना काय अज्युम केलं की कॉलमचं वेट त्यांनी काय केलं, निग्लेक्ट केलं. सेल्फ वेट कॉलमचं निग्लेक्ट केलं. थर्ड अझम्पशन, कॉलम इज लॉंग अँड फेल ड्यू टू बेंडिंग ऑर बकलिंग ओनली. That means he derived the critical load for long column. त्यांनी इथं मेन्शन केले कॉलम हा लॉंग कन्सिडर केलाय, नॉट शॉर्ट. म्हणजेच ही जी काही थिअरी आहे ती कशासाठी आहे, लॉंग कॉलमसाठी. द मटेरियल ऑफ कॉलम इज परफेक्टली होमोजिनियस, आयसोट्रॉपिक अँड ओबेज हुक्स लॉ. होमोजिनियस मीन्स ऑल ओव्हर देर इज अ composite material, single material, that we can call it as homogeneous. Isotropic, that means at each and every point stress and strain values are same. Okay, and obeys Hooke's law, that means stress is directly proportional to the strain. This condition follows by this long column. He has assumed, he had assumed this condition. Next assumption, he has assumed that column is initially straight and of uniform lateral dimension. Okay, so what he assumed? He assumed that column is straight and uniform lateral dimensions. Lateral dimensions means this is the 3D view of column. This length, okay, so this will your height, or you can say length of the column. So length is the longitudinal dimension. What are the lateral dimensions then? Width and depth of the column. So B and D are the lateral dimensions of the column, and he considered these are the uniform throughout. Throughout म्हणजे टॉप पासून बॉटम पर्यंत जे काही डायमेन्शन आहे कॉलमचं वरती तेच प्रत्येक क्रॉस सेक्शनलला सेम बी आणि डी असणार. ठीक आहे, असं अज्युम केलेलं आहे. म्हणजे परफेक्ट स्ट्रेट पोर्शन आहे. चारही फेसेस जे आहेत कॉलमचे ते स्ट्रेट आहेत असं त्याने अज्युम केलं. The stresses are within elastic limits, that means Hooke's law. Okay, stresses are within elastic limits, that means they obey the Hooke's law. Next, seventh, plane cross section of column remain plane and normal to center line during buckling. So plane cross section of the column remain plane. If you take the cross section of the column and if it is a plane, then after buckling also or during buckling also it remains plane. He has assumed that. Okay, and normal to the center line. Normal to the center line means this is the axial or center of the column. So if we take the cross section like this, so this one is the plane. Okay, so this plane is a rectangular type or circular type. So this plane remains plane after buckling or during buckling. Okay, without bending, buckling or wrapping. Okay, so he assumed these 7 assumptions. Okay, let's see next. Okay, so by using these assumptions, he derived the formulae to calculate the critical load. You can denote it as PE. Okay, PE for different end conditions of the column. So there are 4 end conditions of the column. So instead of deriving the derivations, I have directly mentioned the derived formulae which are useful to solve the problems. Okay, because in your theory, in your exam, there might not be chances to ask the derivations. Only the problems will be asked in the theory, in your paper. So that's why I have excluded that derivation part and I have directly taken the formulas. So first let's see what are those formulas, and in the next lecture we are going to study the problem on the basis of these 4 formulas. So case 1 is both ends of column are pinned or hinged. For that case we know that actual length or effective length is nothing but the actual length is equals to the actual length. So our equation is critical load for this condition, critical load of column for this condition. How we can calculate the critical load? By this formula, pi square E I minimum divided by LE square is nothing but the modulus of elasticity. All of you know what is E. Okay, I is nothing but the moment of inertia. So minimum I means minimum value of between the Ixx and Iyy. Okay, so we have to calculate Ixx and Iyy, and comparing these two values, we have to take minimum value between these two as a I minimum. Then second case, when both ends of the column are fixed, then by using this formula we can calculate critical load acting on the column. So P will be equals to 4 pi square EI divided by L square, and as L is the actual length, so effective length will be equals to L by 2. Okay, so this is the formula you have to use to calculate the critical load when both the ends of the column are fixed. Then next one is, third case is when one end is fixed and other is hinged. then you have to use this formula 2 pi square EI upon L square, where effective length will be equals to L by root 2. Okay, for this case. So by using this equation you can calculate the critical load acting on the column when column has one end is fixed and other end is hinged. And last end condition for the column is when one end of the column is fixed and other end is free, then you have to use this equation that is pi square EI minimum divided by 4L square. L is nothing but your actual length, and what is the relation between actual length and effective length for this end condition? LE is equals to 2L. So by putting LE is equal to 2L in this equation, our equation become pi square EI minimum divided by LE square. So by using all these formulae, you can calculate the critical load with respect to particular cases. Okay. So in next lecture or in next video, we will going to study one by problems on these 4 cases. Okay. Thank you. Please, if you like my videos, if you like my or understand my lecture videos, then you can subscribe, like and share my channel. Thank you.